Let's try to. All right. So again, I'm going to show you how to design a circuit, right, to display a dice, right, that have outcome 0, 1, 2, 3, 4, 5. So first, we try to create truth table first to see. we know that 5 outcome we need 3 inputs, right? So I'm going to say x, y, and z, right? And the outcome that we want are those A, B, C, D, E, correct? So how do we get A, B, C, D? This, right? Represent H. Make sense? H dot, right? A, B, C, D, E. Okay? So let me increase the size a little bit. So we have inputs and we have output, right? So this is the input section and this is the output that we want. Now, the first one is when all of them are 0, right? Right. So these are LED that we represent. We talked about LED last time, right? The lights. So when they're all 0, that means this is going to be all 0, correct? Right. So now we said, okay, we want E to be 1, right? At that point, E is 1, right? So E is 1. And the rest is going to be 0. So we can say, okay, whenever it's 001, we're going to make E1 as input, right? Let me center it. And maybe just change the color a little bit. All right, so we have input and output, so then we can distinguish it. Now the next one is what are the ones? A and C, right? So we said when A and C are ones, right? So O, 1, O. Okay? That's O, 1. So that's 2, that's 3, right? So that's going to be, with 3, it's going to be AEC, right? AEC, A, C, E, right? And 4, E is 0, so the rest are 1. Five, when opposite are 1, right? So 5, 1, 0, 1. And then it's going to turn out the rest 1. So we have the cases that we actually don't care, right? Input can be anything. We don't care, right? All right, so once we get this, we can start to see this, right? These are midterms, right? We talk about midterms, right? So let's see, first we get the truth table. This is truth table. And we want to construct the Boolean expression from truth table. And we said input is X, Y, and Z. Correct? Equals to X, we're going to say X prime, Y prime, Z prime, right? Plus, correct? So this is X prime, Y, X prime, Y prime. We're interested to look at all the ones, right? So we want to construct the Boolean expression how, right? So let's see. If this is X prime, Y prime, Z prime plus X prime, we have to say first in order to get A, right? F A is this is A, right? F X Y Z is going to be equals to all the ones here. Talk about ones here and ones here, right? All the ones here. I want to create the expression for A, right? Boolean expression for A. So equivalent to x prime y z prime plus x prime y z plus x y prime z prime plus x y prime z. If I yeah, I keep typing z is close to x. Alright, let's review again. X prime y z prime, right? X prime y z x y prime z prime x y prime z. That's how we construct A. And from here, you know what you need to do, right? Simplify it, because this is not simplified yet. Using Boolean algebra or K-map. So I'm going to assign someone do that for me. If you do it correctly, I'm having a class.
Ooh.
Oh. So we have 4 cupcakes.
Ooh.
All right. So we want to have cupcakes that is delicious. So yes, and it's stuffed with blueberries inside. So you have to make sure you get this right. So B, we look at all the ones, right? So it's going to be x, y prime, z prime, right? Plus x, y prime, z, right? So that's the one. Now we have z, right? So that's the third Boolean expressions. So the Boolean expression is gonna be all the ones again. It looks the same as A, right? So A and C, right? And D is the same as B. So B and D, right? Then last one is E, right? So other ones, so that's gonna be X prime, Y prime. Oh, I use lowercase, okay. X prime, Y prime, and Z, right? Plus X prime, Y, and Z, right? Plus X, Y prime, Z. I keep typing Y. All right, so we pretty much just got all the Boolean expressions, right? Now we need to simplify, right, to create a K-map. and from K-map. So let me explain the, like for example, the equation that we have, right? Let's download Logism at the same time because we decided circuit, correct? And I think I told you to prepare this program, right? This is just a program to pretty much just do the circuit wiring. Right. There are many of those, but happen to pick this one first. Happen to use it first. Some of them may be even better.
I think one might tell you obviously that one had some updates on
Oh, very nice.
somewhat recently.
Doesn't see my Java. Okay. Let me try to run again. Try to close out the program. Okay. Okay, let me try what you said. The other one, what's the name? Logism
One that I got, the CHR
Evolution. Yeah, Java is good then. This one?
See different stores for it, I generally don't use them.
Alright, so that's jar. Okay. So let's say, for example, if I have equations, right? My equation, how do you simplify so far? What's simplified version of this? So we need to simplify it, right?
I felt like X plus X prime.
So set x plus x prime.
That's what I got. I know it's wrong. I'm trying to figure out what it's wrong.
That's gonna be 1 plus x. Why not? All right, so we can do K-map together if you want to check. But before that, let's show you. Right, for example, like I said, I'm not going to verify that. Someone verify for me. We already talked about how to do K-map, right? So if I get that equation as simplified, meaning that I need to put my inputs, right? And when you see plus, that's OR, right? So you just draw, this is how you draw the circuit, right? That's OR, right? I need one OR, I need two AND, right? Because that's two AND. Like I said, I'm not going to verify it. It might be wrong. If it's wrong, then you're not going to get output that we want, right? Like when I place it, it's supposed to turn on my A and C, right? According to the input here, which we can make. I think this is an input, right? I need three inputs, right? X, Y, and Z, right? You can label it too, then you won't get confused, right? So X, okay, Y, and Z, right? Oops. Now we need to AND, right? So I'm going to get to n. Okay, so I start to wire. We need not to, right? Correct? Not. So this is not. Okay. So one way to do that is I like to put a knot down here. Whenever you have knot, you can just wiring it to the bottom. The top is like not the knot, right? Now let's do wiring. I think the finger is the one, right? Or either one of this. Let's see. So this is X, right? So when you put it in here, then the output should be X naught, right? And we said X naught, right? We want X naught to go into the first AND, right? So I can just put X naught into the first AND. And then we want Y, just Y, right? X naught and Y. Okay, so we get X naught and Y plus X, right? X, so we need X. X, so let's make this X to go down to here, right? X and Y naught, right? So we need Y naught. So when we put in naught, it's going to be Y naught. Right? And then we go wiring it to OR. And then we have the output. Now output is, this is represent A and Z, right? So we need to have the output should be your LED or the lights. There you go.
And not.
So I'm gonna put, just like example, the question is, right? They want 5 LEDs, right? 2, 3, 4, and 5. And if you want to put label, then you won't get confused. If you want to, that's fine. Just according to the question. A, I think it's clockwise, right? B, C, D, and E. All right, so we said, let's double check if I put it correctly. A, B, C, D, and E. Okay. And now we said A and C, right? So this has to go to A and C, right? A and C, right? So we're gonna keep doing that for the rest of the expressions. Then we pretty much just done, and then we can test by with all 0, right? This all 0. When, let's test A and Z, right? That one, right? When Y is 1, let's start with change this to 1, right? I think, let's see, we can simulate it. Let me save this. dice. Right. So it's light up according to what we want. When it's 010, it's gonna give 2, right? Let's verify. There you go. So we just design exactly 2. That means you simplify it correctly, just 10, right? If you don't simplify correctly, then you see that why we need to simplify. You reduce the work. You don't need 3 ORs and tons of n and not. See that? And that's how you create circuit. So let's finish that up. Guess we still have some time. So what's an okay, Justin, you can have your cupcake. Before you go, please take it. All right, so who's gonna show me the next expressions? Who wants the cupcake? That should be simple, right?
The next one is X1.
Just xy, right? All right. So we also have the last one. Who has the last one? All right, so let's do the last one. Okay, I'm going to wiring xy first for B and D. So meaning that xy is for B and D, right? Xy is and, correct? Just take to and, right? Wait, right? So I need another and, correct? So take the and in. Let's just put it on top. And we need to wire x and y. Just take it from here. I'm not wiring nicely. Someone just make it very nice. Where do we go? B and D? So we connect it to the light B and take down here and D. All right, last one. No? No one want cupcakes? Why not Z and plus, you mean? Plus X not Z. Okay. Everybody have the same thing? Please verify because we don't know if it's going to be correct. But when we put it in logic, it's going to tell you too, right? Yes. You mean this one? Then you have to talk to Colin then. It's X, why not? Okay.
Oh yeah, you're right.
Okay.
Because why not times I completely forgot to do that.
All right, so we have to rewire this then. So I don't. Then we learn how to delete your wiring. Just click on it and hit delete key, right? You say why not, right?
Yeah, why not?
Then
Come on, you're making me look bad.
all right. So last one. Why not Z and or right X not Z? Can you verify that, please? Why not Z? Why not? So it's gonna be. I will need 2 N and 1 OR, right? 2 N and 1 OR. Let's take 2 N. Let me know when it's incorrect, okay? Then then I don't have to rewiring it. Why not Z plus X not Z, right? X not Z, yeah. Why not Z? So why not? So I need why not, which is here. Why not? And Z, right? Z. And it's connect to OR. And this guy go to E, right? Okay, I have Y naught Z or X naught Z. X naught Z. Oops, that's Z, right? It's all connected together. Let me get. That's why you have to be careful when you're wiring here, right? Have it be the same line. Let me just put X naught from here. Okay. Of course, I'm not a designer, right? I'm a developer, right? I can create it. It works. But this time maybe nah. Okay. All right. So let's test then. Let's save this. Of course, you have to save it first. Otherwise, I don't think they will let you do that test, right? All right. So 000, right? It's 0. 001. Voila, we get 1, right? And 010, 2. 011, 3, right? And then we say 100, 4, 101. You guys get cupcakes. Easy? So the thing that we learned is put them all together. You make circuits. Now you can invent any circuit that you want. Right? It's just create a truth table. Let's revise again, right? Real quick. All right, so we understand what we want. We need to know how many outputs. According to outputs, 2 to the power of inputs, you get output, right? So we need at least 3 bits because 5 outputs. So we start to construct the truth table. So 3 inputs, 5 outputs, right? And then we just decide whenever user make 000, then we set all the outputs going to be like that, right? And then our output is going to be 1 and so on, right? This is easy one, 0, 1, 2, 3, 4, 5. Then we have the dice that's going to light up, right? According to the inputs. From there, we're interested to just look at these are pretty much your expression for each output, right? That's Boolean expression. You have 3 inputs, you get 1 output, right? Which is fxy is your output. So that's why we have 3 expressions that we need, right? And some of them happen to be the same, so we can share it, right? Then we end up with 3 expressions. And from there, of course, you can do AND OR right away, but it's going to take forever and consume too much resources. So simplify. Now you understand why your algebra is so important when you were a kid and try to simplify and say, I don't like it. Now you know the benefit of it. You gotta like it. And then we got the best solution ever. You see that we reduced to just 1 A and 1 not. And then we just do writing it. So this is simulator. Now if you want to make a real one, just go and purchase that gates and wire, switch, and lights and power source. Then you make your own dice. Make sense? This is a simple one. Now prepare for the test. So you can have the circuit that you can imagine and you have to design it. So practice it. It's going to be easy for the test. Okay. Say it again. Oh,